Hello, today we'll look at linear equation in one variable. So, as written here, a linear equation in one variable is an equation that can be put in the form ax plus by equals c. Okay, so this here is generally the form of a linear equation, where a, b, and c are constants, but a cannot be equal to 0. For example, here we have some linear equations showing that what the variables or the constant a, b, and c are. So in the first example, here is a, here is b, and here is c. So a is equal to 5, b is equal to 3, and c is equal to 2. In the second example, we have a is 2. There is no other term, okay, on the left side. So realistically, b is 0 here, and c is 7. In my next example, a is 5, b is 12, and c is 0. So that's the reason we say that a cannot be 0, because if a is 0, we'll have 0 times x plus 3 is equal to 2. 3 is equal to 2, and we know this is not a correct statement. Okay. Now, as we discussed in our one of our videos, we talked about factoring and terms. So here we have 5x plus 3 equals 2. So a is 5, b is 3, c is 2. Each of these are called terms. When we solve, we get an answer. And that answer, as we know, is the solution set. The solution is the set of all real numbers that, when used in place of the variable, makes the equation true. Okay? So this here makes our equation true. We will see that two or more equations with the same solution are called equivalent equations. So if we have two or more equations with the same solutions, what does that mean? Well, if we have, for example, 2x minus 5 is equal to 9, and we have x minus 1 is equal to 6, you will see that if x is equal to 7, then this equation here becomes equal, because 2 times 7 minus 5 is equal to 9. 14, 2 times 7 is 14, minus 5 is equal to 9. So we have 9 is equal to 9. So x equals 7 is a solution. Yes. On the other hand, if x is equal to 7 here, we have 7 minus 1 is equal to 6. 6 is equal to 6. So x equals 7 is also a solution for this equation. It's also a solution. Okay? That means that this tells us x minus 5 equals 9 and x minus 1 equals 6 are called equivalent equations. And it doesn't have to be two, it could be two or more, right? So anytime we have two or more equations that have the same solution, we can refer to them as an equivalent equation. Now let's look at the whole solving process. Okay. For example, if you're asked to solve 3a minus 5 equals to minus 6a plus 1. So this is also a linear equation with one variable. While you're only seeing one variable, and the variable here is a. Okay, our variable here is a. These are variables. The only difference now is that we have variables on both sides. So what do? Well, some of you were told that the variable have to be on the left side. Some of you were told it has to be on the right side. Some of you were told it doesn't matter. Now, if you have a method that works for you, then use it. If you were told that it has to go on the right side, you can put it on the right side. Generally, it does not matter. What I like to do, I always like to move the variables first, and I always move the smaller variable. So a suggestion is to move the smaller variable. In this example, minus 6 is smaller than positive 3. So what I'm going to do, I'm going to add 6a to both sides. Now I only add 6a because I'm crossing that equal sign. If you don't cross an equal sign, the sign should not be changed to a positive. And you will see in a minute what I'm referring to. Okay, so notice that we have here a negative. Okay, and when I want to move it across the equal sign, I opposite the opposite sign. So what do I have left? Well, 3a plus 6a becomes 9a. I bring down the minus 5 equal minus 6 and plus 6 becomes 0 when you add them. We generally say in math that they cancel out. But if you add them, it becomes 0. And that's equal to 1. Now we want to leave. Remember, our goal here is to isolate the variable. Okay? Our goal is to isolate the variable. So what we will do is move the minus 5. Now once again, we're going across an equal sign. So I will add 5 to both sides. Okay? And if I add 5 to both sides, what do I have left? The 9a stays. The minus 5 and the plus 5, when you add them, become 0, equals 5 plus 1 is 6. Okay? And now we have to get a by itself. Now I'm multiplying, okay? 9a equals 6. I am multiplying the 9 and the a. So the opposite of multiplication is division. So I divide both sides by 9. And 9 divided by 9 becomes 1a, and we have 6 over 9. Well, generally when it's a 1, we don't have to write the 1. We can write a is equal to, and 6 over 9 can be simplified. Okay, you can divide this by 3 and this by 3, so that becomes 2 over 3. Okay? As a reminder, if you divide the top by 3, you have to divide the bottom by 3. So a happens to be 2/3. A is what is our solution, or we can say the solution set. Okay, the solution set is, in curly braces, 2 over 3. So we're not going to really use this a lot right now, but I just want to show you, if we write this as a solution set, it has to be in bracers. Okay? Now you should, always perform a check. Okay, you should always go back and plug this value in to your original equation, which we have up here. Okay, replace a with 2/3 and see if the left side is equivalent to the right side. Sure, you should perform that as a check. So let's do that. We want to do a check. Let's do a check. Let's confirm. Check. So we were given 3a minus 5 is equal to minus 6a plus 1. And now let a equal 2/3. So what we do, we replace everywhere we see a, we replace it with 2/3. Okay? Every time I see an a, I'll replace my a with 2/3. Now we distribute, we multiply these two. So keep in mind, 3 is the same as 3 over 1. So if you want to multiply the fractions, you can see that. So 3 times 2 is 6. 1 times 3 is 3. Minus 5 equal. This is like minus 6 over 1 times 2/3. So this becomes minus 6 times 2 is minus 12. 1 times 3 is 3 plus 1. Now if you notice, 6 divided by 3 is 2 minus 5. And negative 12 divided by 3 is negative 4 plus 1. 2 minus 5 becomes negative 3. Minus 4 plus 1 becomes negative 3. So the left side is equal to the right side, and that's true. So you have confirmed that a is equal to 2/3, and we say it checks. So that has checked. So this is how anytime you do a problem, you should check your answer at first to make sure. You should always check your answers to confirm that it is correct, especially at this point where you're learning how to do this. You should check your answers. I may not check all answers in the video, but I strongly suggest that you check your answers because it's very easy to make simple errors in algebra. Let's look at this next example, because in the first example, I made a comment that if you move variables across the equal sign, the sign change. How about if I have this example? 5a minus 7 plus 3a is equal to minus 4a plus 1. Yeah, you're still seeing one variable as an equation, so it is a linear equation with one variable. Now, you will notice that in this equation, okay, you have a, 5a, and positive 3a on the left side of the equation. Now, because you can combine those two, you can combine these two by just adding them. 5a plus 3a becomes 8a. Okay, notice that I did not, okay, I did not minus 3a and minus 3a here, because there's no equal sign that I crossed over. So you do not do this. Okay, it's a very common mistake. We do not do that. So all we do is combine the 5a and you take the signs with them. Okay, you take the signs. So 5a plus 3 becomes 8a minus 7 is equal to minus 4a plus 1. Now, as I suggested before, this is not a rule, it's just a suggestion. I always like to move the smaller variable first. So we have here 8 and minus 4. And as you know, the more the negative or the more the number is on the left of the number line, the smaller it is. So since we're crossing the equal sign, we go plus 4a, the opposite of minus, and plus 4a. Okay? And usually I do that in blue, so let's redo that. Plus 4a plus 4a. Okay? Now, if I combine positive 8, positive 4 becomes positive 12a. Bring down the minus 7, and now this minus 4 plus 4 becomes 0, so we just write plus 1. Now I'm going to move the 7, so what I'll do, I will add 7 to both sides, because I'm crossing that equal sign. So what do we have left? We have 12a minus 7 plus 7 becomes 0, as we say cancel out, and 1 plus 7 becomes 8. Now we have 12a is equal to 8. So what we do now, so the opposite, since this is multiplication, we'll divide by exactly what we want to get rid of. There's a plus 12, we divide by plus 12. Divide by plus 12, okay? So the 12s become 1a, okay? That becomes a 1, equal 8 over 12. And as I said, we generally don't have to write the 1, so a is equal to, and here we can simplify again. Now we can divide this by 4 and divide this by 4. 8 divided by 4, okay, becomes 2, and 12 divided by 4 is 3. So 2 over 3 again. So you can see these were actually equivalent, right? Because in the first problem we had a equals 2/3 also. There's a coincidence. So these two problems, this problem here, okay, and the first example, although they're different equations, they are equivalent. That's the check. So this one here, okay, they're equivalent. Just pointed that out to you. Now, keep in mind you should go back and check your work, okay? You should perform a try. Try to check. Try to check your answer. You should do that. Now, generally, example, solve. When you're asked to solve an equation and you have fractions, we tend to freeze up. We tend to get nervous because most people, when they see fractions, get scared. Okay? Now, you don't have to work problems with fractions. The answer could be a fraction, but you don't have to solve your entire problem with a fraction. Sometimes it's easy, but you can get rid of the fraction. And the first thing we will do to get rid of the fraction, we'll find the lowest common denominator. So pick a number that 3, 2, and 8 goes into evenly, okay? And that number has to be bigger than 8. So let's say we try 8. 8 is divisible by 8. 8 is divisible by 2, but 8 is not divisible by 3. So 8 is not that number. Then we double 8, we try 16. 16 is divisible by 8. 16 is divisible by 2, but 16 is not divisible by 3, so 16 is not the number. Then we take 8 and we triple it. So 3 8s, 24. 24 is divisible by 8, 24 is divisible by 2, and 24 is divisible by 3. So the lowest common denominator is 24. Okay? Now that we have the lowest common denominator, Okay, and it doesn't have to be the lowest common denominator. Any common denominator will work, but the lowest, then you work with smaller number. What I'm going to do is take 24 and I will multiply that by every single term. Okay, I will take 24 and I will multiply that 24 by every single term that we have. Okay. Now, if you want to put it in parentheses so it doesn't look confusing, you can do that. Okay. Now, you will notice that whilst doing this, that something unique happened. 24 and 3 can be reduced. 24 divided by 3 is 8. So when you multiply now 8 times 2x, you get 16x. Okay? Look at what I'll do again. 24 is divisible by 2. 24 divided by 2 is 12. And then you take that and you multiply it here. 12 times 1 becomes plus 12 equals, look at what we do again. 24 is divisible by 8. 24 divided by 8 is 3. Okay? And then if you multiply 3 times negative 3, that becomes negative 9. So now you have what is called an equivalent equation. These two equations are exactly the same. Okay? They are the same. Now you're probably asking, how can they be the same? Well, think about this. When you were dealing with fractions, is 1/2 the same as 4/8? They look different, but they're exactly the same. Okay? And that's exactly what we did here. This equation can be simplified by dividing throughout, okay, by 12, right? If you divide every one of these numbers here, you will get back that equation that I have. I think I said by 24. I should have said 24, by 24. Okay? So that's where this equivalent comes in from, but you don't have to worry about that. Good. Now, let's solve for x. Remember, the solving process is to leave the x by itself. So what I'm going to do, since I'm going to cross an equal sign here, with the plus 12, I will minus 12 on both sides. Okay? And if I minus 12 on both sides, the 16x comes down, plus 12 and minus 12 becomes 0, and minus 9 minus 12 becomes minus 21. Okay? So now we want to leave x by itself, so 16x. Now we want to get rid of the 16, so we divide by exactly what we see, 16 on both sides. The 16 divided by 16 becomes 1, so this becomes 1x is equal to minus 21 over 16. Now this is algebra, okay, so we could leave improper fractions improper. Okay, the top number is bigger than the bottom. You don't have to simplify it to mixed number. So we have x is equal to minus 21 over 16. Now, I don't think 21 over 16 could be simplified, so you leave it as that. Now, keep in mind, okay, notice I wrote the negative on the outside, or you could write minus 21, everything over 16. these two things are written the same. Okay? The negative can be on the outside, and maybe I should exaggerate that more, it can be on the outside, or it can go in the top. We generally don't put it in the bottom, but you can put it in the bottom if you want to. Let's move on with some more examples, because you know, the more example you try, the better you become at this. Examples. Solve. And now I have 5x plus 2 minus 4x plus 1 is equal to 3. Okay. So, I mean, you know the rules from algebra. You've heard of PEMDAS. So always look inside the parentheses first. Is there anything in here for you to simplify, meaning like terms for you to combine or anything like that? And if there isn't, then you go down your list. There's no exponent, so we move to multiplication. So 5 times x becomes 5x. 5 times positive 2 becomes positive 10. Minus 4 times x becomes minus 4x. Minus 4 times 1 becomes minus 4. And that's equal to 3. Now, if you look on the left side, we have what is called like terms. Okay, we have a 5x and minus a 4x. There is no equal sign between them, so you could just combine them. So 5 minus 4 becomes 1x. You don't have to write the 1. If you look carefully again, we have a plus 10 and a minus 4. There's no equal sign between them, so 10 minus 4 becomes positive 6. And that is equal to 3. Now we want to move the 6. Okay, we want to move the plus 6. We're going to take it across the equal sign to this side here. So what do? We minus 6 on both sides. And if you minus 6, we end up with, we don't have to write the 1. X plus 6 minus 6 becomes 0. And that is equal to plus 3 minus 6 becomes negative 3. Okay? So your solution is x equals minus 3. And keep in mind, you should check, right? Try to check. Okay? You should always check it. So different equations have different way of solving, but the idea is that you have to leave x by itself. And as I said before, it doesn't matter if x is on the left side or x is on the right side. It doesn't matter of the equal sign. So what happens too if you have an equation that involves some sort of a decimal? Okay. So let's look at example. Solve 0.7a minus 4 is equal to 0.02a plus 1.1. So similarly, I mean, decimal is just a different way of writing a fraction. Okay. So what I do, I look at each one of these terms here. So I notice if I wanted to make this into a whole number, I would have to move this decimal one place. Here it's already a whole number. Here, if I wanted to make this a whole number, I have to move it two places. And here, if I want, I'll have to move it one place. So the most amount of move is equal to 2. That's this one here. Okay? So what I'm going to do, I'm going to take my equation I'm going to move every single one of them 2 places. So 1 would bring me there, and I move it again. And in this space, I put what is called a placeholder. So this now becomes 70, 70. I will take this decimal here and I'll move it 2 places. 1, 2. Okay? And in here, I put placeholder. So this becomes minus 400 equals. I will take this decimal and I will move it 1, 2. Okay? So this becomes 2a. I will take this decimal 1, 2. It's there and placeholder there. So this becomes plus 110. And now we have an equation without any decimal. So the goal is to look at the problem and see every term how many places you have to move them and pick the one with the most amount of moves. Okay? So let's solve now. So I'm going to minus 2a on both sides. Okay? And if I minus 2a, 70 minus 2 becomes 68a minus 400. The plus 2 and the minus 2a cancels, and that is equal to 110. So now I'm going to move the 400, the negative 400 across an equal sign, so I have to add 400 on both sides. And if we do that, we have 68a, this becomes 0, is equal to 400 plus 110 becomes 510. Now we can divide both sides by 68 to leave a by itself. This cancels out. So we have 1a is equal to 510 over 68. Notice you can simplify this. How do I know that? Anytime the number ends with 0 or an even number, it's always divisible by 2. So I'm going to try 2 since the number is big to see if you can see it. So 510 divided by 2, 2 2s are 4, 2 5s are 10, 2 5s are 10, that's 255, divided by, okay, 68, 6 divided by 2 is 3, 8 divided by 2 is 4. So we have 255 over 34. And I don't think that that can be simplified anymore, so we'll leave it as that. Okay. So final answer, A is equal to 255 divided by 34. So we're all looking at linear equations, okay, one variable. There is another type of equation that I want to introduce to you, and that's called quadratic equations. Okay, so let's look now at solving quadratic equations. Okay, so remember a quadratic, okay, if you recall when we did factoring, okay, a quadratic equation is written ax squared plus bx plus c. Now it's an equation, okay, equal 0. And this is what we call the standard form. Okay, Okay, standard form of quadratic. And please keep in mind that a cannot be equal to 0, because if a is 0, right, if a is 0, then you will just end up with that part, which becomes a linear equation. Now, quadratics are not linear. Okay, quadratics are not linear. So let's go back. I know we've done this before. Some examples of quadratics. Example of quadratics. We have 2x squared plus 3x plus 1 equals 0. Okay? Or we have 5x squared is equal to 2x minus 1. This also is quadratic, but this one here is not written with or as, I should say, equals 0. Okay? So when we solve this, you will have to see what I mean by this here. So just put a star here for now. Okay? Star. Or we can have 2x squared equals 24. Here the b term is 0. Okay? Now it is very important to note, okay? So please note, solve a quadratic equation, the equation must be equal to 0. Okay? It has to be equal to 0. I strongly recommend it for you. There's a few cases if b is 0, then you know we're okay. But I don't like that, and I'll show you why anyway. Okay. So if we have, right, for example, x squared is equal to 16. And let's guess the value for x. Well, most of you will say, hey, x is equal to 4. But this is only partially correct. And I'll show you why, and this is why I strongly suggest that it's equal to 4, equal to 0. Now, if we set this equal to 0, so there's a way to get this correctly, okay? You can take the square root of both sides, but you have to put the plus or minus, and which is what most people forget. So if we set it equal to 0, okay, let us take x squared equals 16 and set it to 0. So meaning we will minus 16 on both sides. And if we do that, we have x squared minus 16 is now equal to 0. Okay. Now you learn that we can factor this. This is difference of squares. So by factoring, okay, we have x squared minus 4 squared is equal to 0. So x minus 4 times x plus 4 is equal to 0. Remember, each one of these is called a factor. Now, to solve, set each factor to 0. So we have x minus 4 equals 0 and x plus 4 equals 0. Now we can solve these linear equations. We're going across an equal sign, so I add 4 to both sides. So x is equal to 4, which is one of the answers we guessed. And now if you minus 4 on both sides, x is also equal to minus 4. So there's two answers, because you know if you had squared a negative 4, you still get 16. Now another way, right, and some of you can do this, another way to solve x squared is equal to 16. It's a much shorter way, but the problem is that some of us, to get rid of the square, we'll take the square root of both sides. But when you take the square root of the right side, you have to put that plus or minus, okay? Which we talked about in when we did exponents. So now these two things will cancel out, and leaving us with just x plus or minus the square root of 16 is 4, which really means that x is equal to 4 and x is equal to minus 4. So you do get the same answer. Yeah. I generally prefer where you set it equal to 0, because most of you have heard of the quadratic formula, which can also be used to solve these types of equations. But for now, I'm only going to be solving by the factoring method, because we've only done factoring. So how about if I ask you to solve x squared minus 2x minus 24 is equal to 0. You should note that this is quadratic, and one way to tell, class, that it's not linear is that you have a power that's bigger than 1. Okay? Now, when you're solving quadratic, you know how to factor. Okay? Can you factor the left side? So we've done factoring in prior video. So here just to a is equal to 1, right? B is equal to minus 2, and C is equal to minus 24. And then in the side work, we always multiply A times C, which is 1 times minus 24, which is minus 24. And then we look for all the factors of minus 24, which will be 1 and 24. One of them has to be negative, because this is negative. If you look at B, B is negative, so the bigger one will keep negative. 2 times 12, this is negative, the bigger one. 3 times 8, the bigger one is negative. 4 times 6, this is negative, and this seems to work, right? 4 times 6. If you add them, you get negative 2. So I'm going to replace this guy here, okay? We now have x squared plus 4x plus 4x, okay? Minus 6x minus 6 minus 24 is equal to 0. So what I'm doing, this is being replaced with these two here. That's what we did factor by grouping. And now I perform factor by grouping by splitting the problem in half. So the GCF here is x. If you take out x, we have x plus 4. The GCF on the right side, always take the sign, minus, and that becomes 6. So if we take out a minus 6, we have x plus 4. A negative divided by this negative makes it a positive. Notice that my parentheses are the same, so we're okay. And that's also GCF again. So if you take out x plus 4, you would have x minus 6 equal to 0. Now take each factor, set it equal to 0. So we subtract 4 on both sides. So x is equal to minus 4. And we add 6 on both sides. So x is equal to 6. So here are my two solutions. Keep in mind, these are called your factors, okay? And this is called your solutions, okay? Factors, solutions. Big difference between factors and solutions. And you will see later on from the solution, you can get the fact. Let's look at another example, okay? Where we want to solve let's say x squared. Solve x squared is equal to 5x plus 6. So please observe, this is quadratic. Okay, it is quadratic because the highest power is 2. So we have to set equal to 0. Set to 0. So what I'm going to do, I'm going to minus 5x on both sides. So that gives me x squared minus 5x. These are not like terms, so you can't combine them, okay? And that is equal to, this cancels out 0, 6. It's still not equal to 0, so next I will minus 6 on both sides. If I do this, I have x squared minus 5x minus 6 now equal to 0. It cancels out, but we have to put the 0, okay, as a placeholder. And now we're going to factor this here. So I'm not going to go through all of the steps. A here is equal to 1. B is equal to minus 5. C is equal to minus 6. So I'm going to replace this here. And we have x squared minus 6x plus 1x minus 6. Okay? Because if you add these two guys with the signs, you will get this. So you'll have to multiply a times c and look for the pair that add to give a negative 5. Now, factor by grouping, which I'm not going to go through like I said, because you have to be acquainted with this by now. If you factor this, you will get, take out an x, you will have x minus 6. Take out a plus 1, you're going to have x minus 6. So we have x minus 6 times x plus 1. And that is equal to 0. Don't forget, we have to set each step equal to 0, and I hope I did. They're supposed to be equal to 0 here also. Has to be equal to 0. So now x minus 6 is equal to 0, and x plus 1 is equal to 0. So we add 6 to both sides. So we have x equal to 6, and minus 1 on both sides, x is equal to negative 1. So just as a note, right, as a note, the highest power here is 2, okay? Highest power is 2. And you will notice we have two solutions, yeah? You will see that the power tells you the most amount of solutions you will have, okay? If we look at another example, solve x cubed plus 2x squared minus 9x minus 18 equals 0. Now this is not quadratic, okay? This is not quadratic. So we cannot say A, B, and C. But a hint here is that you have 4 terms, okay? You do have 4 terms. So hint, 4 terms, okay? And we said that if we have 4 terms, we can trifactor by grouping. So the GCF on this side is x. If you take out an x, you have x squared plus 2. Actually, that's an error. The GCF is x squared because this is the highest power, x squared. So if you take out x squared, you will have x plus 2. The GCF on the other side, GCF, remember I said this sign always goes with it, so it's minus and we have a 9. So if you take out minus 9, oops, different color. If you take out minus 9, we have x, a negative divided by a negative, okay, becomes positive 2. You will note that these two parentheses are the same. So that means we have a GCF again of x plus 2. So if you take out x plus 2, we have left x squared minus 9 is equal to 0. And now please note, we have 2 factors, but notice that this factor can be factored. It's difference of squares. So this comes down, x plus 2, but this one here becomes x squared minus 3 squared, okay, which is x minus 3 times x plus 3. And don't forget, this one here is still have x plus 2. So now we have 3 factors, and this is what I'm saying, because the degree, the power, kind of give a hint what's the maximum amount of factors you will have. So now x plus 2 is equal to 0, okay? X plus 3 is equal to 0, and x plus 3 is equal to 0. And generally we say or since we're solving, okay? Should have been an or. because we're looking for solutions. Okay? So minus 2 on both sides, so x is equal to minus 2, or add 3 to both sides, x is equal to 3, or minus 3 on both sides, x is equal to minus 3. The reason we say or, because any one of these, you plug it into that equation, will work. Okay? Any one of them, not both or not 3 at the same time. So the last example I'll do is to show you that something very unique. Example, solve x squared, okay, plus 6x plus 9 equals 0. Now you should see that this is quadratic. So by factoring, a here is 1, b is equal to 6, c is equal to 9. So if you replace the positive 6, you will have x squared plus 3x plus 3x plus 9. Okay, 3x plus 3x is 6x. Don't forget it's equal to 0. And if you factor, you will have x plus 3 times x plus 3 equals 0. Now x plus 3 is equal to 0, or x plus 3 is equal to 0. And you minus 3 on both sides, so x is equal to minus 3, or x is also equal to minus 3. So now notice that you have only one solution. This is what I was trying to say earlier. Notice that the degree, note, the original problem x squared plus 6x plus 9 equals 0. The degree is 2. The degree, right? The degree tells us the most solution we will have. This means or implies we will have 2 solutions, 1 solution, or no solution. No solution is always an option. So in this case, what happens is that this turns out to be our indicator. For this problem, we only had one solution. There are going to be problems that you have no solutions. Okay? There will be problems that will have infinite solutions. So just to point out of a problem with no solution, it doesn't have to be quadratic, but let's try it. Let's try to solve. Okay. 2 parentheses 3x minus 4 is equal to 3 plus 6x. So we know there's nothing in the parentheses to simplify, so the next step is to distribute. So if we distribute, we have 6x minus 8 is equal to 3 plus 6x. And now I always move the letters first. It doesn't matter, they're both 6's, so let's minus 6 on both sides. If we do this, we have this cancels with this. Minus 8 is equal to 3. This also cancels with this. And you will see that this here is not possible. So this problem has no solution. There is a problem with no solution. So this is why we say, and look at what happened. The power of this problem was a 1, right? The degree of the variable is 1. So this means you will have one solution or no solution at all. Okay. Now some problems will have infinite solutions. Okay. Example, solve. Suppose I have minus 15 plus 3x is equal to 3 parentheses x minus 5. Now we have a parentheses and there's nothing to simplify, so we will distribute. We will distribute in this side. So on the left side stays the same, minus 15 plus 3x is equal to 3x minus 15. And as always, I move the letters first. You don't have to. We minus 3x on both sides. And by doing that, we end up with minus 15 plus 3x minus 3x is 0 equal to plus 3x minus 3x is 0 minus 15. Notice that the left side is identical to the right side. They are identical. And whenever they are identical, it means that this problem is an identity, which implies that we have infinite solution. Meaning any number you try will work. If you take x and you plug it in as 0, it will work. If x is 1, it will work. If x is negative 5, it will work. So any number will work. Okay. So problem varies. Every problem is different. Notice that I give you quadratic and I didn't say solve by the quadratic formula. That's an option to solve, but we haven't got the quadratic formula yet at this point in my videos. So we'll leave the quadratic formula. You can use quadratic formula, it doesn't hurt. But more importantly, you should try to solve additional problems on your own. Thank you.